You probably know Isaac Newton, and maybe even the lesser known Gottfried Wilhelm Leibniz. These were the creators and founders of calculus. To most people, that is where their knowledge stops. But there are many other mathematicians who built off Newton and Leibniz's works. One of them is who we'll be talking about in this video, Augustin Louis Cauchy. Born in 1789 in Paris, France, to a family of politicians of the French Revolution, Cauchy was already off to a bad start. His family had to flee to Arcueil, a southern suburb of Paris. After the execution of Robespierre in 1794, they returned to Paris where the family friend Lagrange, who is best known for his equation Lagrange error bound, recommended he enroll at École Centrale du Panthéon, the best secondary school in Paris. Fast forward a couple of years, and Cauchy is now graduating from École des Ponts et Chaussées in civil engineering with the highest honors. This engineering career only lasted 3 years before he got bored and remained on unpaid sick leave. The new King Louis XVIII, after Napoleon was defeated, appointed Cauchy to the Académie des Sciences, where Cauchy was welcomed with hostile arms. He was not well liked by his peers after replacing 2 members of the Academy who were removed by the king. Cauchy received a 1-year contract for teaching math to second-year students at École Polytechnique and was promoted to a full-time professor when several of his colleagues were fired. His time as a professor was marked when he released his book Cours d'Analyse. This book rejected the principle of generality of algebra, which was commonly used by Euler and Lagrange and a variety of other mathematicians at the time. The generality of algebra assumes that algebraic rules that apply to certain classes of expressions will apply to a larger class of objects. Cauchy rejected this idea and stressed the importance of rigor in analysis. Also included in his book was one of the first explanations for the notion of convergence and the theory of series. He created an absolute convergence test called Cauchy's condensation test in a textbook he gave to his students. He also contributed to many basic formulas for the Q-series. But the most well-known and important theory Cauchy created and rigorously proved was the complex function theory. He was the first to define complex numbers as pairs of real numbers. Then he developed Cauchy's integral theorem in its full form in 1825, and then he formally defined the residue of a function in 1826. While in Turin, Italy, Cauchy submitted 2 papers to the Academy of Sciences of Turin. The first describes Cauchy's integral formula, and the second presents the residue theorem. Cauchy's work did not really get a response until 1840 when Pierre-Alphonse Laurent created a substantial contribution. Cauchy also stated and proved the mean value theorem in its modern state, despite it sometimes being called Lagrange mean value theorem. While also proving and describing his famous formulas, Cauchy left France because of the July Revolution and moved all around Europe. He spent a short time in Freiburg, Switzerland, and was a foreign member of the Royal Swedish Academy of Sciences. He then moved to Turin, where he taught for a year as the chair of theoretical physics, a position made specifically for him. In August 1830, he moved to Prague, where he was named a baron and a science tutor for the Exon Crown Prince and grandson of Charles X, dethroned in France because of the July Revolution. He returned to Paris in 1839. He was reinstated at the Faculté des Sciences on March 1st, 1849, as professor of mathematical astronomy, where he taught for the rest of his life. Cauchy died from bronchial condition at 4 a.m. the 23rd of May, 1857, at 67 years old. While not the most famous mathematician or the most well-liked, it is inarguable that Cauchy's contributions were important to calculus and to our understanding of the world as a whole.